Hydrodynamic offloading of diabetic foot with the MEDICOVI insoles. The MEDICOVI insoles water wave balance technology is a completely new technology used in the design of orthopedic water-filled insoles. This is a completely new and unique technology where the water in the insoles moves continuously, giving protection of the diabetic foot and thereby preventing the development of foot ulcers. Records from 2014 from the Danish Health Protection Agency showed that approximately 22,000 people suffer from foot ulcers in Denmark. Moreover, 3,000 additional people with diabetic foot ulcers are expected to emerge every year. Amputations of the toe, foot, or leg were performed on approximately 2 diabetics per day, typically due to foot ulcers. Approximately 4,000 diabetics live with an amputation. The Danish Health Protection Agency estimated that the cost in 2012 of new patients over a year developing diabetic foot ulcers cost society about 800 million crowns. Investigations have shown that neuropathy is the cause of approximately 70% of all diabetic foot ulcers. Neuropathy is virtually always a later complication for those suffering from diabetes, mostly brought about by the disease damaging the body's very fine blood vessels. The MEDICOVI insoles protect the diabetic foot through completely new and dynamic orthopedic principles. The hydraulic pressure in the water immediately distributes the pressure load across a much larger area of the surface of the foot, which reduces the pressure on the most exposed areas. The continuous movement of the water reduces an intensive massage movement of the foot sole. This interrupts the shoe's fixing and passivating of the sole, as well as reducing the time the body weight places on the load of the exposed area of the sole of the foot. The continuous movement of the water simultaneously distributes the load across the complete sole of the foot, thereby allowing the energy storage in the dermis's connective tissue cells to last longer, thus significantly increasing the cell's ability to protect the foot's sole tissue, blood vessels, and nerves. The body's micro-movements of the construction of the insoles allows massaging water movements as well as simultaneously developing small and extremely fast-moving water movements that activate sensory nerves over a very large area of the foot, immediately giving better balance. By improving balance, the MEDICOVI insoles will quite significantly reduce the negatively escalating pressure load spiral, which is a significant participant in the development of foot ulcers, while neuropathy is developing in the sole of the foot. Poor balance increases the pressure load and leads towards foot ulcers. We will now elaborate on our view of the problems with the diabetic foot and therewith how the MEDICOVI insole's new hydrodynamic offloading works in relation thereto. Let us begin by looking at the very fine blood vessels. The very fine blood vessels are a combination of a small blood artery, a small capillary, and a small vein. The energy supply enters into the cells in the form of oxygen and glucose under pressure through the capillary walls, while the waste products return to the capillary through the vein end. The constriction, which clog up the every fine blood vessels, are virtually always a late complication of a diabetes sufferer. These constrictions are a process which happens over time and takes place in all of the body's very fine blood cells. These constrictions cause a reduction of the blood flow in the blood vessels. As the blood vessels narrow from the build-up constrictions, there is a consequent reduction in the speed with which the cells are supplied with energy. The plantar skin layers are separated as follows: the hypodermis, the dermis, and the epidermis with the growth layer. The bacteria causing the foot ulcers will generally develop in the transition between the dermis and the growth layer of the epidermis. We shall now concentrate our discussion on this area. The epidermis attaches to the dermis by means of a growth layer of stem cells. The stem cells continuously produce new cells. They grow towards the surface where they are slowly dying, forming a callus, flatten, and then are finally worn off. The epidermis, for the majority of people, renews every 2 months. The dermis consists of a very strongly interconnected open structure of resilient connective tissue cells, additionally providing the skin with a greater strength and resilience. It also forms a protective structure around the nerves and blood vessels. This prevents damage of these soft tissue parts from the impact of the body weight on the sole of the foot. The connective tissue cells in the dermis uses energy with the support of the body weight simultaneously provide protection of the nerves and blood vessels. As previously shown, energy is supplied through the blood vessels capillary in the form of oxygen and glucose. When the connective tissue cell is not under load, the cell is able to absorb sufficient glucose, allowing the cell to store usable energy for times of heavy load. The work that the connective tissue cells are able to generate in order to carry the body weight and subsequently able to protect the nerves and blood vessels in the dermis is the result of pressure or weight of the body to which the cell is exposed, multiplied by the time with which the pressure influences the cell. The energy to perform this work comes partly from the energy, which during the same time period is conveyed into the cell through the capillary and also partly through the cell's energy storage. As we run, there is an increased load on the ball of the foot from the body weight. However, the time this load is on the ball of the foot is very short. When we stand, the ball of the foot will carry a smaller portion of the body weight. Conversely, the time may also be very long. As you can see, there are a great variety of loadings to the connective tissue cells in the foot's sole dermis. The energy supply through the capillary is an ongoing process, whereas the load against the dermis connective tissue cells varies considerably. The energy storage in the connective tissue cells therefore acts as a buffer to be used by the cell when the ongoing energy supply from the blood vessel is not sufficient, relative to the energy being required by the cell in order to handle the actual load. The connective tissue cell's energy storage is of great importance, enabling the cell to carry the body weight as well as simultaneously providing protection for the nerves and blood vessels. If the energy balance is exceeded, i.e. the load on the connective tissue cells has been so great and the time so long that the cell's energy storage has been exhausted, the cells will no longer be able to maintain their carrying capacity and will be completely compressed by the body weight. The connective tissue cells will lose their protective structure around the blood vessels, and the compressed, thus restricting or blocking completely the flow of blood. Also, there will be increased pressure against the nerves. This development, which for many generates pain and discomfort in the sole of the foot as the day wears on. For a diabetic, 2 factors influence the energy balance in the connective tissue cells in the dermis. During the time load occurs, and the greater the constrictions are in the fine blood cells, the lower the flow through the blood vessels and the less oxygen and glucose energy will reach the connective tissue cells. Simultaneously, with the increase of the constrictions in the blood vessels, there will be an added risk for the diabetic that the connective tissue cells' energy balance will be exceeded, generating an increased pressure against the nerves and the blood vessels in the strained area. If the diabetes is poorly controlled, it will be more difficult for the dermis connective tissue cells to absorb the glucose by using insulin. Figuratively speaking, the cell wall is rejecting the insulin and the assimilation of the glucose will take longer or will be reduced. This means the poorer the control of diabetes, the less efficient will the cell's energy storage become, and the faster the energy balance in the connective tissue cells will be exceeded. With diabetes, the connective tissue cell's energy balance is reduced, partly by the increased constriction within the blood vessels and partly by the cell's resistance or lack of ability to absorb glucose from the injected insulin. The connective tissue cells in the dermis must carry the body weight, and the reduction of the connective tissue cells' energy balance, which is often over time a consequence of diabetes, resulting in a reduction of protection of the body load, provided the connective tissue cells of the nerves and the blood vessels in the dermis. In the beginning, we were intended to walk barefoot on hard and uneven surfaces. The unevenness from that surface would make the body weight continuously vary the strain of the sole of the foot. The movement of the sole of the foot would increase the strength of the foot, as well as the thickness of the sole of the foot. Today, we walk in shoes on level surfaces. The level surface removes any movement of the sole of the foot that would normally occur. The shoe, at the same time, will keep the foot in a fixed position and concentrate the weight of the body on a few small areas of the surface of the sole of the foot. The pressure on these small areas of the surface of the foot will always place pressure loads on the outer layers of the dermis. From there, the pressure will expand across greater and greater areas of the dermis and the subskin and finally be absorbed by the foot's bone structure. These outer layers of the dermis are exactly where the nerve sensory organs are placed, as this provides the most sensitive warning system. The result of this pressure concentration, it follows that the connective tissue cells in these most loaded areas require a large amount of additional energy in order to maintain their protective structure. If the pressure and the time the pressure is applied exceeds the connective tissue cells' energy balance, the cells will lose their strength and the protective structure around the nerves and blood vessels will be reduced. A pressure will occur which will be at its greatest against the nerve's external protective mantle, which will squeeze the blood vessels in that protective mantle together and will reduce the supply of oxygen and nutrition. The actual nerve fibers are electrically isolated within the protective mantle, where the cells inside require oxygen and nutrition in order to maintain this function. Around each individual nerve mantle, there is very fine mesh of blood vessels, which supply the nerve mantle with oxygen and nutrition. If there is a reduction of the supply of energy to the protective mantle of the nerve due to constrictions in the very fine blood vessels, some of the cells in the protective mantle will die, reducing its isolating capacity. The nerve's ability to pass on information to the central nervous system suffers or declines. The energy supply to the protective mantle may even reduce to the extent that the nerve will lose its ability to function completely and neuropathy will develop. Surveys have shown that the cause of 70% of all diabetic foot ulcers is from neuropathy. With neuropathy, the nerve's protective mantle is deteriorating, which weakens the nerve's signal power, and neuropathy will develop. The nerve's protective mantle has deteriorated to the extent where the nerve has ceased functioning and neuropathy has developed. As shown previously, if the pressure and the time of the application of pressure exceeds the connective tissue cell's energy balance, a compression pressure against the nerve's protective mantle will occur. This pressure will squeeze the blood vessels in the protective mantle together, reducing the flow of blood in addition to any reduction previously caused by the buildup constriction. If neuropathy has developed in the sole of the foot, the likelihood that it will also develop in other areas where there is pressure concentration increases. This will be located exactly where the load has exceeded the connective tissue cell's energy balance. We are never stationary. The body will always sway just a little backwards and forwards. The greater the sway, the worse our balance. Normally, we do not have any conscious influence over our balance. Balance is usually only controlled by our subconscious. Only when the natural sway becomes excessive do we start to register a lack of security. By leaning a bit forward, an increase in pressure on the front of the foot will follow. The balancing system depends on feedback from the sensory nerves in the sole of the foot in order to be able to initiate corrective muscle movements, which will guide the body back to the point of equilibrium. Should this feedback to the balancing system from the sensory nerves be poor, The muscle movements for recovering balance will be late to initiate and greater the sway will be. Largely, the balancing system receives poor information from the sensory nerves because we wear shoes. This is because the fixing characteristics of the shoe concentrates the body load on a few small areas of the foot. In these loaded areas of the sole of the foot, where the pressure is the most concentrated, there is a high probability of neuropathy developing. If neuropathy occurs here, the information to the balancing system is poorer, automatically reducing balance, as evidenced by the natural sway increasing. When the sway increases, a greater portion of the body's weight will be over a longer period of time by loading the same exposed areas of the surface of the foot. If neuropathy develops in the sole of the foot, there will be a reduction of balance and consequently, the natural sway will increase. Following an increased sway, the body's pressure and the time which this pressure is loading the exposed areas will increase. Simultaneously, the greater the sway automatically put very strong additional pressure on the toes, which is why the skin layer of the toes can become heavily overloaded when the sway increases. The increased load pressure, the result of the worsening balance, will furthermore restrict the energy supply to the nerve mantles as well as the connective tissue structure in exposed areas of the sole of the foot, thus spreading the neuropathy to even more nerves. As more nerves suffer from neuropathy, the balance will further reduce, and this creates a negative spiral, where the neuropathy will reduce the balance and the reduced balance will furthermore generate additional neuropathy. The development of this leads to foot ulcers in the diabetic and is unable to detect since the neuropathy has rendered the nerve's warning system defunct, making the diabetes unable to feel pain. The body's load pressure and the time this pressure lasts corresponds to the degree of work the connective tissue cells in the dermis must carry out. In order to be able to carry the body weight and at the same time be able to protect nerves and blood vessels from overloading, the connective tissue cells will gain energy to carry out this work. Partly from the energy flow which the cells receive from the neighboring blood vessels, capillaries, where the flow of blood once again is restricted by the amount of deposits in the blood vessel, and partly from the cell's internal energy storage, where the size and efficiency is also dependent on how well the illness is controlled. When neuropathy occurs in the sole of the foot, there is always a reduction in balance. The reduced balance increases the pressure as well as the application time of the pressure to a great degree, particularly against the outermost layers of the dermis connective tissue cells. When the energy balance in the connective tissue cells is loaded in an area and has been surpassed, the energy storage in the cells will vanish. When this energy storage goes, the cells will lose their strength and consequently collapse. The collapse will compress the blood vessels and furthermore reduce or completely stop the energy supply to the connective tissue cells as well as to the stem cells in the outermost growth layer of the epidermis, where this is underneath the loaded area. When the stem cells lose their energy supply and a reduction in their reproductive capacity, they deteriorate, leading to splits between the dermis and the growth layer. When the growth layer deteriorates, the moisture and the elasticity disappears from the underlying cells and the skin dries out. When the outer layer of the skin dries out, cracks occur, through which bacteria may reach the split between the growth layer and the dermis and cause an internal inflammation. Due to the neuropathy, the diabetic will not be aware of this until the inflammation condition has advanced so far that it will break through the outer skin layer and create a foot ulcer. Hydrodynamic offloading of diabetic foot with the MEDICOVI insoles. The MEDICOVI insoles water wave balance technology is a completely new technology used in the design of orthopedic water-filled insoles. This is a completely new and unique technology where the water in the insoles moves continuously, giving protection of the diabetic foot and thereby preventing the development of foot ulcers. The construction of the MEDICOVI S100 consists of a soft and comfort-generating EVA upper sole with an underlying water-filled functional pressure water wave massage sole. It is this new and unique water wave balance technology which is the foundation of the construction of the water-filled pressure wave massage sole through a technically controlled movement of water, providing a significant effect in the prevention of diabetic foot ulcers. When load from the body weight reaches the pressure wave massage sole through the sole of the foot, a huge hydraulic pressure is generated in the water. Due to a very strong construction method of the pressure wave sole, the hydraulic pressure will push a water film beneath the majority of the foot's surface. As there can only be one hydraulic pressure in a liquid, hydraulic pressure will distribute the load of the body across a very large portion of the surface of the foot. The result is that the hydraulic pressure in the MEDICOVI insoles reduces the pressure load in the exposed areas of the surface of the foot. Via changes in the body's center of gravity, powerful and relatively slow movements in the water in the pressure wave massage sole will generate, forcing an intensive massaging movement of the sole of the foot due to the hydraulic pressure. Standing on MEDICOVI insoles, one can clearly feel how the body weight moves the water pressure around the surface of the foot continuously, thus interrupting the shoe's fixing of the foot. This massage-generating water wave therapy works independently of any existing neurotherapy in the sole of the foot. As the massaging water wave therapy continuously moves the body load around on the sole of the foot, there will be a reduction in the time with which any given pressure caused by the body influences any exposed area on the surface of the foot. The massaging water wave therapy thus reduces the time which the pressure influences any loaded area. As most women are aware, if discomfort or pain occurs in the sole of the foot, changing shoes will help. The shoe always fixes the foot in such a way that the body weight will always put a load on just a few areas of the surface of the foot. When pain occurs, the load of one of these areas has required an amount of energy which has exceeded the cell's energy balance and used the internal energy storage. The cells will lose their carrying capacity, collapse, and result in a painful pressure against the nerve. When changing shoes, the new shoe will fix the foot differently, and the body weight now places a load on a different area of the surface of the foot, where the energy storage in the dermis connective tissue cells is still sufficiently large enough to carry body weight without discomfort and pain. By changing shoes, the connective tissue cells' energy storage on the other areas of the surface of the foot are utilized. Imagine if we were able to change shoes 100 times a day, and all the shoes fit the foot differently. We would be able to utilize the energy storage in all of the dermis connective tissue cells, and there would be very little chance of feeling discomfort or pain in the sole of the foot. When resting, the energy storage in the connective tissue cells is reestablished. When standing or walking, the connective tissue cells require energy, and usually the blood flow in the fine blood vessels are able to provide the connective tissue cells with new energy during all the phases of the moving pattern, where the load on the cells is low. For the diabetic, constrictions in the dermis fine blood vessels reduce the blood flow, taking longer to supply the cells with new energy, also taking longer to reestablish the cell's energy storage during daily loading of the foot. In addition to this, because of the illness, the connective tissue cells may have difficulties absorbing glucose, energy. The buildup constrictions in the very fine blood vessels, depending on how well the illness is controlled, increases the risk of the energy balance in the connective tissue cells, during the load being exceeded, causing the cell's protection of the tissue, blood vessels, and nerve in the areas where the load is specifically severe to disappear. The individual connective tissue cell's energy balance is thus, on one hand, dependent on the energy the cell needs to carry its share of the load in a given time. On the other hand, the individual connective tissue cell's energy balance has to be covered by the energy cell at the same time as it is fed through the very fine blood vessels, plus the energy that the cell in less congested periods have been able to build in energy storage. For the diabetics, it reduces the energy balance of the construction in the very fine blood vessels, as well as the cell's ability to utilize the given insulin. If the cell's energy balance is exceeded, the cell loses strength and thereafter its ability to protect the nerves, blood vessels, and tissues. We have previously shown that when we go with shoes on flat surfaces, the weight of the body will largely load a few small areas of the surface of the sole of the foot. Looking at the two cells in the sole of the foot, where cell 1 is located in one of the loaded areas, and where cell 2 is located outside of one of the loaded areas, then we can see that these two cells have two completely different options for protecting nerves, blood vessels, and tissues. Cell 1 will constantly be loaded and the time between each burden will be short, which means that the opportunity to get energy is limited, i.e. the energy balance of cell 1 easily risks being exceeded. Cell 2 is nearly not loaded, i.e. that this cell has a good energy balance with a filled energy storage. However, the cell cannot help cell 1, as the shoe fixing means in particular that the body weight loads cell 1 first. Only by moving the load from the body to cell 2 can the energy stored in cell 2 be used. Since this is exactly what the MEDICOVI insole's hydrodynamic offloading does, it means that the energy balance in the sole of the foot can be utilized much better. The MEDICOVI insole's massaging movements of the sole of the foot, where the weight from the body is being moved around continuously on a large part of the surface of the foot, bringing efficient use of the diabetic's limited energy storage in the dermis connective tissue, corresponding to changing shoes about 100 times a day. Simultaneously, the massaging water wave therapy will ensure a greater period between the loading of the individual connective tissue cells and allowing the limited blood flow in the very fine blood vessels more time to supply the required energy. The MEDICOVI insole's massaging water wave therapy will better utilize the available energy in the dermis connective tissue cells, allowing an increase in protection of the tissue, blood vessels, and nerves in the sole of the foot. In their report, Dr. Med Fine-Vossen-Moller and Professor Michael Voigt have defined the MEDICOVI insole's general function, a sensory massage or water wave therapy, which they have defined as continuously variable pressure relief of the area under the sole of the foot, continuous stimulation of the muscle activity and the movement of the foot, increased awareness relating to posture and balance. The sensory massage or water wave therapy will thus increase the blood circulation in the feet and legs and create a continuous and positive variation in the distribution on the strain of the feet, knee, hip, and back. The use of the MEDICOVI insoles will thus generate a general increase of comfort as well as a reduced risk of ongoing difficulties with the locomotor system. The MEDICOVI insoles improve balance immediately. The construction of the pressure wave massage sole will allow, alongside the massaging water movements, the development of small and extremely fast-flowing water movements within the sole. These small water movements generated via small micro movements of the body's center of gravity are distributed extremely quickly across the whole of the pressure wave massage sole surface. Here they activate the sensory nerves in the sole of the foot with fast and clear signals of the body's smallest movements. The balancing system will react instantly to this activation of the sensory nerves by improving balance, simply by reducing the natural sway. The MEDICOVI insoles water wave balance technology will in this way, on a pure mechanical basis, provide an instantly improved balance. It is easy to feel how the extremely fast water movements in the MEDICOVI S100 create a powerful reinforcement of the influence within the sensory nerves. Placing the fingers from one hand on a MEDICOVI S100 as shown in the picture, followed by pushing very gently with the finger from the other hand on the insole's heel, one will immediately experience just how quickly the water movements influence the sensory nerves in all the fingers touching the sole. If you do the same experiment with a conventional insole, you will only feel a reaction on the sensory nerves in the fingertips within the yellow area only. Obviously, placing any pressure on the heel of a conventional insole corresponding to the action of the fingers on a MEDICOVI S100, only the sensory nerves in the yellow areas will activate. Placing pressure on the heel of a MEDICOVI S100 corresponding to what we have just done with the fingers on a conventional insole, hydraulic pressure will build up immediately and quickly in the MEDICOVI insole. The hydraulic pressure will immediately create extremely fast water movements, and they will influence the complete area in the heel and the front of the foot in contact with the insole. The implication of this is the amount of sensory nerves being activated by the body's movement will be considerably larger compared to those activated in the yellow area of the conventional insole. As well, the sensory nerves in the front of the foot will activate sooner than they would normally be the case. It is this combination of this activation which mechanically provides improved balance. The fixing of the foot by the shoe means that the balancing system is primarily receiving sensory information from the sensory nerves in the relatively small pressure areas on the surface of the foot. These are exactly the pressure areas where there is also a likelihood of developing neuropathy. Development of neuropathy as one of these exposed pressure areas will therefore have a relatively large influence on balance, which will worsen and increase any natural sway. The larger sway will also give rise to an increased pressure from the body and an increased time during which this pressure influences the exposed areas. A negative spiral thus develops where the neuropathy causes a degradation of this balance, which in turn will further aid in the development of additional neuropathy through increased pressure loads. With each small micro-movement of the body, the extremely fast water movements in the MEDICOVI insole will activate a considerable group of the sensory nerves in the sole of the foot with faster and clearer signals about the body's movement, thus improving balance. By using the MEDICOVI insoles, the development of neuropathy in any of the exposed areas will have a lesser effect on balance. By improving balance, the MEDICOVI insoles will significantly reduce the negative escalating pressure load spiral normally created by neuropathy in the exposed areas in the surface of the foot and which is forming the germ leading to foot ulcers. Under the management of Professor Pascal Madeleine and Professor U. Kersting, the Center for Motor Interaction, Aalborg University, has carried out a scientific analysis of the MEDICOVI insole's influence on balance, which has documented the insole's static as well as dynamic balance improving characteristics. In addition to the advantage achieved through better balance, there are also the MEDICOVI insole's offloading characteristics, as mentioned previously and repeated briefly below. Through the hydraulic pressure in the water, the pressure waves massage sole distributes the pressure load across a larger area of the surface of the foot, reducing the pressure against the most exposed areas. The massaging water wave therapy also continuously forces the sole of the foot to move. This interrupts the shoe's fixing and passivation of the sole of the foot and reduces the time the body weight places load onto the exposed areas of the sole of the foot. The massaging water wave therapy simultaneously spreads the load across the whole of the sole of the foot, thereby extending the time the energy storage can last in the dermis connective tissue cells. Correspondingly, the cell's protection of the tissue, blood vessel, and nerves in the sole of the foot. This corresponds to changing shoes 100 times per day. Surveys have shown that the cause of approximately 70% of all diabetic foot ulcers is neuropathy. Neuropathy is virtually always a late-occurring complication in diabetes and will arise from the fact that the illness for the most, over time, will destroy the body's very fine blood vessels. Prevention of diabetic foot will therefore always, to a great extent as is possible, seek to counter or at least delay the problems associated with the development of neuropathy in the sole of the foot. The MEDICOVI insoles hydrodynamic offloading of diabetic foot does not remove the individual diabetic's responsibility for their own feet. This means that the diabetic must, on a daily basis, inspect their feet and the soles of the feet and immediately seek professional help should irregularities occur. This prevention of diabetic foot, which is achieved through hydrodynamic offloading, massaging water wave therapy, and improved balance, can only be achieved through the MEDICOVI insoles water wave balance technology. This is a new and unique technology integrated within all the MEDICOVI insoles. Therefore, all the different types of MEDICOVI insoles are well suited for prevention of diabetic foot. The choice of insole depends on the level the illness is at. The other problems that may be, perhaps in connection with the locomotor system, as well as the work situation one occupies. For instance, if one is using safety shoes, then the obvious choice of the insole is the working insoles, MEDICOVI A40 and A41. There are MEDICOVI insoles to suit nearly all requirements. Neuropathy has been observed in the sole of the foot. It is recommended to use one of the MEDICOVI soles provided with an EVA upper sole, as the pressure relief of these soles is greatest. This applies to the insoles MEDICOVI S100, which is 4.5 millimeters thick, MEDICOVI A40 and A41, which are both 4.5 millimeters thick. MEDICOVI D45, which is 6 millimeters thick, with an additional pressure relief plate under the heel and forefoot. The different MEDICOVI insoles may be ordered on www.diabetes.medicovi.dk or bought through the foot therapist. We thank you for your attention.